Recording in progress.
All right, guys, welcome back to another session on cubic polynomials, if you like. Today we're just gonna spend more time and look at solving equations. Last week, if you'll remember, we introduced the remainder and the factor theorems. These are very key, and we actually showed that they're pretty much related, right? In that the factor theorem is just a special case of the remainder theorem. What makes it special is the fact that the remainder is 0. All right. So I just want to take one question and as an example to show you how actually they can ask questions related to this. So let's look at maybe before this. This is just a recap. So I've got an example here just on the remainder and the factor theorem. We are told that g of x is 27x cubed plus 9x squared minus a 3x plus 7. And this function, or this polynomial, let's call it a polynomial, yes, is divided by 3x plus 1. So given this, we are required to determine the remainder. Now, what the theorem says is the remainder can be found actually by finding the 0 of this equation. So the 0 of this equation is a -1/3. So the remainder will be found when we substitute a -1/3 into g of x. And once again, I want to appeal that someone with a calculator works this out for us so that we save time. I hope you do have your books and your calculators there. All right, who's got an answer for me? I will pause here. Did I catch you guys off guard? You're taking too long for me there. We gotta be fast when using this because you don't have all the time to be doing this substitution in an exam sitting. So I need you to be quite fast. This should at least be one area where your confidence is just there. All right, I see someone has helped me here. 2 answers. Beautiful. We are getting 8. Good. Excellent. Thank you for that. So that means the remainder is 8. Okay. Therefore, remainder is 8. Okay. Thank you, guys. Thank you very much. Please keep those calculators up. I'll need you to help me very much. Right. So we just like that, we have answered the question. But here's an interesting one. Let's look at an interesting one. Okay, let f of x be the polynomial x cubed plus 5x squared plus 2x minus 8. And the first question is, show that x plus 4 is a factor of what? Of f of x. And then the second one will be then saying hence. You see, when a question starts with hence, they're essentially saying as a result of what? Of what you did previously. Sometimes they'll say hence or otherwise. So now that they are giving you an option, you can use what you got previously, or you can use another method which you feel would be easier for you. But usually what you got previously makes life easy for this question that starts with a hence. So hence, factorize f of x fully. So in full. All right. So again, we know that if x plus 4 is a factor of f of x, it simply means we must have remainder 0 when we substitute what? X equals to 4. Sorry, not 4, minus 4. You see, I helped myself by writing this thing down. Okay, so by substituting x equals to minus 4, I expect a 0. That's what I expect. So are you confirming there? Who's confirming for me? Because all you have to do is to find f of negative 4. Lelo gets a 1. Then something is not right. Then that would mean it's not a factor. We're supposed to get a 0. Remember, when you do the substitutions, right, you got to use brackets, right? And then got to be very careful when doing this whole thing. Okay, Lube got 0, I also got 0. So Lelo, you got to check what went wrong with your calculator there. Just check if maybe it was not a case of brackets. So we get 0. Okay, so that's it then. Then that would mean x plus 4 is a factor. So of f of x. So we got a remainder 0, and that's what proves that we've got a factor. Now, the follow-up question says hence factorize. You see, because it says hence factorize, it says to you, look, you have a factor already of x cubed plus 5x squared plus 2x minus 8. You have a factor already, meaning you can write it as x plus 4 times what? Times some other trinomial. We know by now that we will get a cubic expression from a product of a binomial by a trinomial, right? So we got that. Now, what we need to do here is remember the inspection. And as I said, I will keep on using inspection. I don't want you to run to a long division, but to just try and manage and have everyone comfortable, we will get to a point where we will do long division one of the good days. But for now, let us just focus on doing the inspection. I think it saves time. It's just that you have to be really spot on and accurate. But I'm sure as you practice, you're going to perfect this. All right. So now, what is our thinking process here? Okay, our first term is an x cubed. So we're going to say, what should I multiply x by to get an x cubed? Then surely that's an x squared. And then the next thinking is, okay, my constant term is a negative 8. So now what should I multiply 4 by to get a negative 8? And I want to believe you are all thinking a negative 2, because a positive and a negative should give me a negative. All right, signs are very important at this stage. Okay, now once we are done with this, then we say, all right, we need to find the middle term. We need to find the constant term. And this is the term that we referred to as a bx term. I hope you remember that. So this bx term is the one term that you always have to find it. You always have to kind of try and find this term. So there are two ways. I showed you two ways. You can find this b term, actually the coefficient, it's the x term, it has a coefficient called b. So you can find that coefficient by focusing on either your squared term or your non-squared term, which is basically the x term. Now, it's important to look at your binomial trinomial product and notice that if you're going to focus on the squared, the coefficient of the squared term, then you are looking at a situation where you want to multiply x by bx and 4 by x squared. That's what is going to give you the squares. For the x terms, you need to notice by now that you'll get an x term when you multiply x by the negative 2 or rather and the 4 by that. So here I said to you, it's a matter of choice. Any of these options would work. So in the interest of time, I'm not going to go over both. I think I'll just take the green simply because 2x looks like a nice number. So when I start with the greens and I multiply the x and the negative 2, I get a negative 2x. Then when I multiply the 4 and the bx, I will get a 4bx. Now, this must give me a positive 2x, which is my green. Then from here, I will just add like terms. And as you can see, 4bx will equal to 4x. Now, I divide by 4x both sides because I'm solving for b. I want to isolate that. And clearly, b is equal to a 1. What does this mean? It means you have then managed to factorize, at least at this stage, f of x. And we can write f of x as x plus 4 into x squared plus 1x, which is just x, minus a 2. And then, as I always say, I encourage you to check whether this can be factorized further. If you cannot factorize it, you are welcome by all means to use the quadratic formula and find what the roots or rather the factors are. So obviously I do notice this one can actually be factorized. It will be an x plus 2, x minus 1. And these are my 3 factors, and I am now done factorizing this. That's all the question required. It says I must factorize this. And as you see, the emphasis is on the word fully, which means if you just stopped here, you have not factorized this thing in full, because the x squared plus x minus 2 can also be factorized. So once again, I want to stress out the importance of actually reading the instructions per question and following those. You must answer a question to the T. All right, so that's about it as far as last week is concerned. Today, we're just gonna use the same concept, but now we are solving equations. And now this is a skill that is very important, because when you sketch cubic polynomials, or cubic functions rather, you will at times need to find x-intercepts. And finding x-intercepts includes actually factorizing and then solving thereafter. So it is quite crucial that we get to this stage. Now, I will start with sort of your routine questions. Once I'm done using the routine questions, we will get to a part where you now have to solve for variables, because it is also important to know how to do the reverse process. What happens at times, you are given a sketch and then you are given some coordinates or even some information which you need to interpret so that you can actually find the unknowns in an equation. So I'll start with your routine questions, and then after that, I'll do sort of your complex questions, which are not really complex. You will eventually find them routine as you practice them on a regular basis. So I'm just going to take a few questions, a few examples on this one of solving, because there are things that I want to stress out as I solve these. Very, very important things that I would like to stress out here. And I hope you will pay attention and note those little things. It's the little things. So I'm going to start with the example x cubed equals to 3. So we know at most this equation cannot have more than 3 solutions. That degree of the equation tells us actually that the solutions are kept to 3. One of the little things that we see students doing when problems are like this or equations are like this is students are quick to really divide by x, because everyone likes canceling stuff in mathematics. And you do that, I tell you, you have lost one solution already, which suggests you have already then lost a mark at least. So very important that you will get used to actually rewriting the equation in what we call standard form. In other words, have all terms on one side of the equation and 0 on the other side. From here, we're going to take the highest common factor. I hope you also note that there is a highest common factor. Now, whenever you've got an expression or an equation with two terms and you have to factorize, there are two options. You either do the highest common factor, or sometimes you just have to go dots, difference of two squares. But I always say, start with HCF, because even in dots, sometimes you find that there's a need to do HCF. So just know when there's two terms, okay, two terms, two options, HCF dots. Don't think of a trinomial or anything. You're going to complicate your life. So here, my HCF is x, so I've got an x squared minus 1. Look at that, so beautiful. Now, there's your dots. Here's the dots that I was talking about. So I hope you notice this is not fully factorized. So I got to factorize this. So this now becomes x into x plus 1, x minus 1 equal to 0. What does that mean then? I have three solutions. X is a 0, or a negative 1, or a 1. And we stop there because we know the maximum here was definitely 3, nothing beyond that. Right. Then the next one, as I said, I'll take types of equations, different types of equations, variations, so that you're fully aware of this. I want to show you another one. It's a special equation as well. So let's take this one maybe with a different color. On this equation, I need you to note that I've got 2x cubed minus 2 equals to 0. And again, it's a highest common factor situation. But guess what? I actually end up with the difference of cubes. Oh, now I got to remind us now that, oh, hang on, actually two terms is not just a matter of a difference of two squares and highest common factor. Actually, the sum and difference of cubes can feature then. Now, I've deliberately started with this because what often happens is students leave this two to linger and linger until the last solution and they don't know what to do with it. Now, let me say this. Here's a contrast between these two equations. In one equation, I just have x's and I'm actually solving for x. So I cannot divide by the variable that I'm solving for. In this case, 2 is just a constant. It's a multiplier in the equation. So actually, dividing by 2 will not hurt or change the outcome of this equation. So I can literally divide both left hand and right hand side by 2 so that I have a neat equation and I'm not troubled by this 2 that always stays and lingers there. Now you got to remember how to factorize your cubes. We are dealing with cubic polynomials here. So this will be x minus 1. What have I done? I've taken the square root of x cubed. I've brought the sign between these two and I've taken the cube root of 1. So did I say square root? My bad. I meant to say the cube root. So I've taken the cube root of both x cubed and 1 and I just bring the signs between them. To generate the second bracket, this goes back as grade 10. By the way, this is grade 10 work really. I have to square this. So I'm reminding you here. Now I've got to square that. Now the sign that comes next for the x term must be a positive. These signs are always opposite. Now what am I multiplying? I multiply 1 by x. When I multiply 1 by x, I just get an x. The last term, I can guarantee you, will always be positive, and it will also be the square of this other term. And obviously, squaring 1 makes no difference. You still remain with a 1. So this becomes our trinomial. All right. Now, what I need you to also note is the fact that in this case, if you try and factorize this, you're not going to get a solution. Even if you try and do the quadratic formula, it will tell you, hang on, dude, there's no real solution here. In fact, your calculator will just say math error. And the reason for that, you got to think of this part of the quadratic formula called the discriminant. And you will notice that if we calculate the discriminant, we actually have 1 minus 4, which is a negative 3. Sorry, a negative 3. And we know from nature of roots that when delta, the discriminant, is negative, then roots are non-real. We know that. There's a grade 11 now. So this is a part where I need you to see how your topics, concepts are interlinked. And I need you to be able to just look at this quadratic here and say, nah, there ain't no way on earth where this is going to be factorable. But like I'm saying, if you are not sure whether it's factorable or not, go to your quadratic formula and just take the discriminant. The nice thing is that you are given the quadratic formula in your information sheet, so you don't have to memorize it. You just go there and you take this. If once the discriminant is negative, of course, you got to make sure you substitute correctly. Once you see the discriminant is negative, you stop right there. Right. So at this stage, what will happen is that we will note that there is only one real root, and that one real root is x equals to 1. It is not that there is no solution here. No, there's just no real solution for this part. As we have seen, it's because the delta is negative. So there's only one real solution, which is x equals to 1. The other solutions that are there are actually non-real. And those who have a bit of knowledge about further studies and beyond the real number system, you'll know that there are complex numbers, and actually the roots are non-real, meaning they are actually complex numbers. Some of you will find this when you do some math in first year level at university. So it will be stimulating. You will see that the math you are doing here is very little, maybe 5% or less of what is being done in university. So I hope you get excited to do that, some math in tertiary. All right, now let's look at other interesting equations. I'm going to take 2 more before we do some advanced questions or the reverse process. So let's take the one question. I think I like this example. So 2 more examples. This is one but last. So x cubed minus 7x squared is equal to negative 8x minus 16. So again, guys, please, I beg you, I know the temptation here, I'm choosing this because I know the errors that we see. Don't do this. I know someone is going to say, oh, highest common factor, x minus 2. And then here's where highest common factor, x minus 7. But my question to you is, where are you going with this? How is it helping you? What logical method or skill of algebra are you going to use to actually solve this? Go back to the principle that I've given you. I said, always have your equation in standard form. So we're going to have every little term on the one side of the equation. In this case, it happens to be the left-hand side, right? I mean, this is the reason we learned how to factorize polynomials last week. Then what do you do next? You look at the constant term, which is a 16, and you list the factors thereof. 2, 4, 8, and then we're going to go to 16. But as you know, we usually give you something that will work out within the smaller factors. We won't have to go that far. All right. Now, somebody, again, you've got your calculators. You are now armed. I would like to get these answers from you guys. Somebody's going to substitute 1. Somebody will substitute negative 1. Somebody will substitute a 2. Somebody will substitute a negative 2. Let's just try these first 4 options before we explore others. So let's try that, please, and try that as quick as you can. Show me that you can actually use your calculator to your advantage instead of a disadvantage. Because honestly, if you're going to spend a lot of time using calculator, you are using it to your disadvantage, all right? Okay, so I suppose, Lelo, you're saying you substituted 1 and you got a negative 1. Then I suppose 1 is out. So remember, we want a remainder to be 0. That's actually what we are doing here. We are essentially using our lovely remainder theorem, and we want a situation where the remainder will be 0. So I'm waiting for your responses. Let's go, guys. Don't take too long using a calculator. Then that defeats the the purpose. Okay, -1. Oh, -1 makes a 0 remainder. Thank you very much. So -1 is where we got our money. Now, what does this mean? It means, remember, once x equals to -1 gives us a remainder 0, then it means x plus 1 is a factor. Just remember that process, right? It's like you're taking one to the other side, sort of. So that's what it means. So it means when I can factorize this into x plus 1 times some trinomial. Now, what is that trinomial? Well, we know by now that the first term will be x squared, because when I multiply x squared by x, I'll get an x cubed. Now I want a positive 16, but I've got a 1 here. So that means, obviously, it is a 1 times 16 that will give me a positive 16. Now, the next thing that we will do is to hunt down this b coefficient in here. So we gotta hunt this down, and again, you have an option of either going with the squares or the x's. In this case, again, it looks like I like going for the x here. So I will multiply 16 by x because I know that's gonna give me an x term, and the 1 and the bx will also give me that. So it turns out then that bx plus a 16x should give me what? I hope you match it correctly. Should give me an 8x. We are solving for b, which means everything else will be treated as a constant. Now, there's two ways to do this, actually. One way is to see that since we are solving for b, it means x is a constant. So you could literally divide by the constant x. Then you are left with b plus b plus 16 is equal to 8. Then just like that, you notice that, oh, so b will be a negative 8. That's one way to do it. Another way is to say, oh, okay, bx will be a negative 8x, because you are adding like terms, right? So you do the additive inverse of negative 16 both sides. And then still, you're going to find yourself dividing by x. Then you see that, oh, b is actually negative 8. Whichever school of thought you want to subscribe to, it's all good. So now we know that this thing here factorizes into x plus 1, x squared minus 8x plus a 16, and this must be equal to 0. Then your next basic check is, can I factorize this? Are you able to factorize that? Now, if it's a minus plus, it literally means you need an x minus and an x minus situation. And the question is, what are the factors of 16? Two factors of 16, which will multiply to a 16, but also add up to an 8. I hope you do notice that in this case, it will be a 4 and a 4. So we have an x plus 1 there. If really you don't see this and you're struggling, I want to suggest that you really try out the quadratic formula. You would have said minus b plus minus square root of b squared minus 4a, and then you've got that, right? And then this is all over 2a, and you can see for yourself what happens when you press all this into the calculator, and then you tell me. You will notice that in thank you for letting me know that the mic went off. Well done. Thanks. I only saw the text popping up now. All right. So as I was saying, you could use the quadratic formula to get the fact that x is 4 or x is 4 are actually your other solutions. So that's another way you could check whether this has a solution. In any case, we were just asked to solve for x. And I just want to show the guys who are going to use quadratic formula how to write this neatly. So you from this step, you will then say, well, therefore, x plus 1 is a 0, or the quadratic x squared minus 8x plus 16 equals to 0. Then from this one, we get that x is a negative 1, which we already confirmed in this step, so we are not surprised. And then from this one here, if you can factorize, you will notice that x minus 4 into x minus 4 are the factors. If you cannot factorize, please write this thing exactly as it is. You got to write it as it is like that. So these are the two options, okay? You don't have to do both. Then, of course, it's important to conclude that x equals to 4. So as you can see, one factor is repeated. And that does not mean we don't have three solutions. We do. We just established that one repeats. Okay, so this is one kind that you can, again, expect. I just wanted to stress the fact that it's important to write this thing in standard form. Right. The other example that I would like to take is this one. And I am doing this one deliberately to see whether you actually remember one of our discussions last week. And this is the example 7x cubed plus 5x squared minus 3x is equal to 1. I want to believe everyone in here at this stage will see the need to write this in standard form. Now, my next question is, how are you going to check the remainder? What are you going to substitute? And this was the one variation that we had. I want to give you a chance to think around this one. And if you have an answer for me, please do shout out the answer. No takers yet. Right, so guys, this is the one where, remember what I said, you're gonna now do the fraction. So this is where you see what makes this one unique is the fact that the coefficient of the cubed term is not a 1. So last week when we factorized this, and I'm gonna go back to that, here it is actually, I think, no, this is the example that we did today. Yeah, it's this one. If you go back to this one, when we factorize this, we said this is what we're going to try. We are taking, I'm just reminding you in case you forgot, we are taking the constant term and we are dividing it by that coefficient. And we look for the factors of both the numerator and denominator. So basically, we're looking at 3 over 2 as that number which we have to find factors. And that's why we had these different combinations, right? So don't forget that part. And I'm saying this deliberately because remember, you're not using long division. So this is what you need to understand so that you don't find yourself at a stage where you say, oh, but this inspection method only works in this case, doesn't work in this case. So it actually works. So what you need to notice here is that you're just going to have a 1 over 7 because you are dividing the constant by that. But obviously, we're going to have the positive aspect and the negative aspect. And that's the beauty of this part here, because now in this situation, there are only two options. Both, well, 7 is a prime number, but 1 is not a prime number. I almost said both 1 and 7 are prime, but 1 is not a prime number. Please, 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 I beg you, never ever say 1 is a prime number. So now we're going to try and see what happens when we punch in a 1 over 7. We're going to try and see what happens when we punch in a 1 over 7. Okay. The positive 1 over 7 doesn't actually work. So I'm going to try the negative 1 over 7. And I'll pray very hard that it actually works. Did I see that? Am I missing something here? And that doesn't work either. Is there someone trying this as well to confirm with me? 7, that minus 1 over 7. I'll have to go and investigate why this theory is not working. So, oh, okay. Yes.
So both for the positive 1 over 7 and for the negative 1 over 7, they don't work. I just confirmed.
Okay, cool. Now let's try this. Remember, this is one possibility, right? 7 is a prime number. 7 has 2 possibilities. As a 7, you have 2 factors, 1 and 7. So the next combination that we must try, we have to try a 1 over 1 or a minus 1 over 1. Because you have established that this doesn't work for both positives. So is there someone who's going to try? Obviously, we have to try, in other words, a plus 1 and a minus 1. So is there someone trying that? I see some messages in the chats. Okay, they both don't work. Yes, so someone is, are you trying the plus 1 and the minus 1? So we had to, oh, by the way, sorry guys, this is not an IEB thing. It is actually a core math thing. It's a normal math thing.
So, negative 1 over 1 works.
So in other words, a negative 1 is what we needed. Excellent. Thank you for that. So this one works. Thank you. Well done. I appreciate that quick work on the calculator. So we now know, remember what this means now. So you said negative 1 works. So that works. And if that works, it means this is a factor. Just remember that, all right? And now we're gonna go on and factorize x plus 1. And we're gonna find our trinomial. Okay, and then it's gonna be an, okay, let's be careful now. I'm not just gonna say x cubed. I must actually say 7x squared. Sorry, I'm not just gonna say x squared. Remember, the idea is what you are checking is when I multiply this by this, am I getting this first term of the original? So there has to be a 7x squared there. Then the other check that you do is the constant term. You need a negative 1. So obviously to get a negative 1, you're going to multiply a positive 1 with a negative 1. So this one here must be a negative 1. Then the next thing is to go and hunt down that middle term and know exactly what the coefficient of b is. And by now, you know, I'm sure you will predict that I will take the x terms. So I will know I'm going to get an x term when I multiply the x by the negative 1. Again, I plead with you, be careful. It's a negative 1, so you're going to get a negative x. If you just multiply by 1, you're going to get a positive 1. And chances are what? Your solution will not work. So it's minus x. And then the next one that I'm going to do is this one. And that's a positive and a positive, so I get that. Now, what should this be equal to? I need someone to give me an answer. Please make sure you give me a right answer. Otherwise, I'm going to faint from my chair now. Let's go. Who's got my answer? What should minus x plus bx be equal to?
Negative 3x.
Thank you very much. You just saved my life. It is negative 3x. So now we're going to find b, right? So whether you want to divide by x and have a negative 1 plus b is equal to negative 3, or you want to take the x to the other side so that you have minus 2x, is really up to you. Bottom line is we must all get a negative 2 as an answer, which means now this thing is actually x plus 1 into 7x squared minus 2x minus 1 equals to a 0. And I'll leave it up to you. You can check your quadratic formula. So obviously at this stage, x plus 1 is 0, or 7x squared minus 2x minus 1 is 0, which would mean this here is a negative 1, or what? And I'm going to deliberately suggest the quadratic formula here, because I don't see how you're going to do this without the quadratic formula. So that, watch this now. Remember, because you are not factorizing, it's important to show this step where you are substituting. Okay, so someone has substituted. Please help me. I think the roots are just irrational here. So who's quick on their calculator? Okay, so if they did not state, sometimes they say round off to 2 decimal places, right? So I guess if they did not state how you should state, give your roots here, you can just give it as a decimal. So now you see why this was not easy to factorize, because the roots are definitely irrational. And how do I know that they are irrational? Once again, when you check that 4a squared, b squared minus 4ac rather, you are actually getting a 32. And a 32 is not a perfect square. So you definitely know now that you have to use the quadratic formula. So here are the three solutions: -1, 0.55, and a negative 0.26. And I wanted to show you through this example that just because this cannot be factorized, don't make an assumption that automatically the roots are non-real. No, you actually have to check your discriminant. And if, as long as your discriminant is not negative, then you're going to have real roots. And if you are not able to factorize, as it is the case in this example, then you have to go with the quadratic formula. So don't throw away that quadratic formula. We still have our three solutions. Excellent. Now, let's do the reverse. And the reverse process now is where they ask you to find some coefficients in the equation. All right, so this is where there's gonna be some hardcore algebra done here. Like, I hope you put your algebra cap on right now on Super Saiyan mode and all that, because I promise you, I'll call this the reverse math now. This is the reverse of what we have been doing. So let's look at the first example of the reverse. And I'm going to write it in full. So when the function h of x equals to, look at this, 2x cubed plus 5x squared plus ax, ooh, look at that one, plus 12, is divided by x plus 3, right? When this happens, then we are told the remainder is 15. Obviously, the question is find a, or find the value of a, right? Now, this is where student will be a bit disorientated and be like, but what does this mean? How do I box all of this? Don't panic. Think of what we are doing in the forward process. If I know that the function is divided by that, then I know that when I substitute a -3, what is going to happen? They say the remainder is 15. Then I'm going to get a 15. In other words, I need to understand that h of -3, in substituting a -3 in this whole thing, maybe let me not substitute on this step, I'm going to get a 15. That is the long and the short of this whole complicated statement. So let us substitute a -3 and solve for a. So we go ahead, I will substitute. So 2 into negative 3 cubed. And please, 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 I hope someone is there to get me the numbers there. Plus, watch here, you got to substitute the negative 3. And this is 15, right? So this is going to be negative 3 cubed is a negative 27. So we're going to multiply that by 2. And negative 3 squared will become a positive 9. We're going to multiply that by 5. And a positive a times a negative 3 is a negative 3a. Watch that. Signs are usually the downfall of many students at this point in time. So now I'm going to add the numbers on the left-hand side. I have 54 plus a 45 plus 12. So I have negative 3a. And this is an extra step which is not really necessary, but I'd like you to know actually, sorry, my bad. I made a bad decision here. I said negative 27 and then I kept on saying positive. Do you see how errors happen when in mathematics? So I should have said minus 54 when I added these numbers. I should have said minus 54, then plus 45. So, and this whole thing seems to give me a 3. So now that's 15. Then I've got minus 3a is, watch now, is actually a negative 12. No, I'm too excited. 15 minus 3 is a positive 12. So now, yeah, now finally I can divide by negative to get a negative 4. So a is a negative 4. Do you see how it's just a matter of language? And I hope once again you see the point I was making the other day, that it's very important that you actually understand the language of mathematics. Extremely important. Now, we have been doing a lot with the letter X. Let's look at a question where we are not given the letter X, but another letter is given. Find the value of K. Watch this now. If f of, listen to this carefully, they are not saying f of X here now. If f of n is equal to 2n cubed minus n squared minus 5n minus k, if this gives a remainder of 6 when divided by n plus 2. So we are just trying to check, have you stereotyped your mind to just work with X? Or have you understood the principle to a point that the moment we remove X out of the way, out of our functions or polynomials, you will still be able to do this math? All right. So are you flexible now? Don't just get programmed to seeing X, such that the moment there's no X, then things seem difficult. Again, just treat n as X, because that's what is happening. So what they are telling us here, we know now from this that I got to substitute n equals to negative 2, right? So just making that you are aware of that, making sure you're aware. So I'm going to I must know that f of negative 2 is going to give me a 6. This is very, very important to understand. Okay, so now, again, I'm going to substitute a negative 2 in the place of n. Look at how brackets are playing a very important role in my substitution. Because I promise you, you leave out brackets here, you are out. You leave out brackets there, you will maybe get away with it. But please, please, please make sure you use brackets whenever you substitute. Okay, a negative 2 to the 3 is a negative 8. A negative 8 times 2 is a negative 16. Now, watch what happens here. So I'm doing mental math. Of course, you can do it with your calculator. So if I square a negative 2, it becomes a positive 4, but I still multiply that by a negative. So this actually stays a negative. And then obviously here a negative and a negative is a positive, so that's a positive 10. And this is minus k is equal to a 6. Then of course you can use your calculator to work out all this. That's actually a minus 20 plus 10, which is a minus 10. Okay, I hope you note that. So I actually have a minus k minus 10 equals to a 6 here, which means a negative k is actually a positive 16. I'm trying to be careful here, which means I get a negative 16 for the value of k. So again, they are really checking. Have you just memorized this? Like I said, CPF, cram, pass, forget doesn't work in math. You gotta know your stuff. So that is exactly what is happening here. Don't cram this thing because of the letter X. Know the principle so that even when X disappears and just given weird letters, you can still relate and know what to do. All right, so that is very important. Now, let's do another one because this one is even phrased differently. The way it is positioned is different. Watch this. This is what it says. Given f of, now we're going to go back to x. Given f of x, maybe I've used f a lot. Let's use g for Mr. G. So given g of x is x cubed plus, watch this now, kx squared minus 15x plus 9. Given this, listen to the question now. Determine or find the value of k if f of x is divisible by x plus 3. Now, I can tell you now, of course, if you have understood the lesson and what I have been doing so far, I can tell you that you know how to do this question. The only one thing that is going to throw you away is the word divisible if you do not understand what it means. Which goes back to my all-time sermon. Math is a language. Please understand the terminology, the words that have been used in mathematics and what they mean, so that when any word is being used, you actually understand the question and you are able to answer it correctly. So I will keep on emphasizing this. Please pay attention to the words, the symbols, the notation, how we write things, because you don't want to lose marks for something that you could do. That's crying over spilled milk. It's not going to help. It's actually going to hurt. So I don't want you to get disappointed and hurt. You know, after a question paper, you'd be like, oh, this is what I was supposed to do. Just because you couldn't understand the word divisible. So please, and the only way to be exposed to different words is to do as many past papers as you can. Promise you, if you can do at least, you see I'm saying at least, which means minimum. If you can do a minimum of 15 past papers, I will not have to worry about you passing the exam. And when I say pass, remember, for me, 30% is not a pass, 50% is not a pass. When I say pass, I'm talking 70% and above, okay? So you gotta work for that, and you gotta put in a lot of work, okay? If you're not doing sports, your weekends are free. Try and use your weekends towards math. Just practice, practice, practice. You will get used to the language, okay? So divisible means what? It's another way of literally saying x plus 3 is a factor of this g of x. And if it's a factor of this g of x, we then know that it means that x equals to negative 3 will give us a remainder 0. So they want to just confuse you here. Instead of saying find the value of k if the remainder is 0, if the remainder of this thing is 0 when divided by x plus 3, they're using the word divisible. Okay, and this, guess what? This goes back to primary school, which means it's important. All right, now for you it might be too late, but it's not late for your younger brother or younger cousin or sister. It's not late to tell them that pay attention in your math class, even when you're in grade 7 or 6, because these words come to haunt you later, right? So they know, they get to learn that 6 is divisible by 3 means that 6 can be divided by 3 such that the remainder is 0. That's what they're told. That's what they're taught. That's what they're taught, right? So these are the little building blocks that if we forget, they become costly later. So don't be afraid. Don't be intimidated by this. Again, it's the same question. I don't know if you notice we've just been doing the same thing, but the questions have just been phrased differently. Again, examiner playing with terminology. So g of negative 3, in this case, the remainder is 0. So we must get 0 when we substitute negative 3. Oh, this is the implication of this whole thing. So now, let's do that. Let's substitute negative 3. Negative 3 squared minus 15 times a negative 3 plus a 9 equal to 0. You see that? Now, I'm going to cube, obviously, the negative 3. Again, you leave out brackets there. You're knocked out. So this should be a positive 9k. And this should be a positive, I want to believe, 45. And that's 0. Then you're just going to work out all these. You're just going to work out all these, right? And minus 27 plus 45. And then you add a 9. And I get to 27. So it means 9k plus 27 is a 0, which means 9k is a negative 27. That's literally all. That's all it means. Okay. And if this is the case and I got to divide by 9, then k is a negative 3. Done. Done. So as you can see, these things, right, guys, are not really complicated, are not really difficult at all. All right, I'm going to take more of your time for today because I have to do these difficult questions so that when we do cubic functions, you are not at all lost. All right, so that's quite important. Maybe let's do one. Maybe next week when we start, we will start with 2 more difficult examples because very, very important that we do this. Look at this one. There's another example. Look, prove that, and I know when students read the word prove, they feel like the question is extreme. Prove that x plus 3a is a factor of f of x equals to, watch this, x cubed minus 2x plus 3ax squared minus 6a. Prove that there's a factor. What does it mean, guys? Just because there's a 3a, it doesn't mean you should forget your principles. You must note that x equals to negative 3a is our substitution here. So in the place of x, we're gonna hold a 3a, a negative 3a for that matter. And what is our anticipation? We are anticipating to get a 0 when we do that. So let's check. Will that happen? You see, when an examiner brings this, they are saying they want to see whether you actually rely on your calculator to work these things out, or you actually know what you're doing. So you see, everywhere I see x, I'm going to substitute a negative 3a. Now you see the mistake I'm making here. Okay, so that should be a negative 3a. And I pick that mistake because I'm actually thinking about what I'm doing here, which is very important that you do as well. So this becomes that. This becomes a positive 6a. Watch out here, okay? This must be multiplied first to give you 9a squared. And then you're going to multiply the 9a squared by the 3a to actually get a positive 27a cubed. Then you have minus 6a. And look at what is happening now. This will take care of that. This will take care of that. The answer is 0. So without a doubt, x plus 3a is a factor of f of x. We expected a 0, so that's what comes out. Just like that, we're done. All right. Let's take one difficult one, maybe one that includes simultaneous equations, and see how we can do this. This is where now, if you notice, all the examples we have done this far, you have one unknown, which is a letter A. Now, we're going to do one where there are two unknowns, and we still got to solve. Okay, so how do we box this? Well, let me write down the question first. When the function p of x equals to 2x cubed minus ax squared plus bx plus 7 is divided by x minus 3, the remainder is 19. That's our first statement. The second statement is that when the same function is divided by x minus 1, the remainder is 11. We know the classical question, find A and B. And I hope you see there's going to be a repetition here. First of all, we must find P of 3. And of course, P of 3 will give us a 19 because we are told the remainder is 19. And then we must also then find P of 1. P of 1 must give us a 13 because we are told the remainder, 11, not 13. Must give us 11 because we are told the remainder is 11 when this thing is divided by an x minus 1. That's all. You set up those two equations, you solve simultaneously, you are done. You have values of A and B. So I'll leave this to you to do, but what I will confirm for you are the values of A. When you do this properly, you must get A equals to 8, and you must also get B is equal to 10. So for your homework, I'll just give you one question, or maybe this is a bit part of homework, but I'll give you another question to go try. Just see if you have understood today's concept. Okay. Let me just make you notice something. Okay, no, let me just give this. Watch this. If x squared minus 2x minus 3 is a factor of, I'm asking you the same question that we just did, but again, I am playing with words because I want to check. Do you really know your story, or you just memorizing stuff here? Okay, now think about this. If I say x squared minus 2x is a factor of this, then I'm literally saying to you, you can actually write this thing as something times this. So if you notice, in this instance, I am given the quadratic. You are used to being given this, and then you use inspection to find this. But now I'm being too kind, actually, I've given you this. So the nice thing about this is you can actually factorize this and say, oh, this must be x minus 3 into x plus 1. Now, what does this mean? It means that x minus 3 and x plus 1 are both factors of this. Let's actually call this h of x. It means they are both factors of h of x. And if they are both factors of h of x, guess what? It means h of 3 must be 0. But also, h of negative 1 must be a 0. So just like that, you have two equations, and again, you can solve simultaneously for A and B. And again, I'll give you the answer to this one. If you're going to solve correctly and you have understood me, you must get A is equal to a negative 4 and a positive 1 for the value of B. Guys, go and try this and see if you have had this. But not only that, check if your algebra is still on point. So we're going to close it here for today. It means next week we are getting straight into differential calculus. We start in calculus next Sunday. and I look forward to it. We have covered very true, important essentials in doing these cubic equations and factorization. As you will see, they are quite important when it comes to calculus. The understanding we have established today is imperative, is crucial for our next talk, which is calculus and cubic functions. So I wait and hope to see you then in the upcoming week, well, the coming Sunday. Others will see you on Wednesday. Otherwise, guys, let's call it a night. Enjoy the week, and we meet again, same time, same place next Sunday. Cheers.